Well, hello, 6th graders, and welcome to 17.7 Symmetry. All right, so we are going to be able to identify symmetry in all sorts of figures today. So lots of shapes. We're going to figure out, does it have symmetry? And if it does, we are going to draw the symmetry lines in there. All right, so a couple vocab words to get us started here. Line of symmetry. A line of symmetry is when in a figure, if one half is a mirror image to the other half. So when you look in your mirror, if it's exactly the same thing if you would fold a paper in half, everything would line up exactly as you did that. That would mean you have a line of symmetry. If it does not, if you go to fold that or if you look in the mirror, everything does not line up, we call that asymmetry. So asymmetry is not identical on either side of the central line, so whatever line, the mirror line or the folding line. And asymmetry, also known as not symmetrical. So if we can fold it, if it has a mirror image, we say that it has a line of symmetry, and it can have more than one line of symmetry. If it does not, then we say it has asymmetry or not symmetrical. All right, so let's identify some line symmetry here. Our directions say to decide whether each of the figures has line symmetry. If it doesn't, we're just going to say, right, no symmetry, does not have it. If it does have line symmetry, if we could fold it somehow, it has that mirror image, then we're going to draw all the lines of symmetry. So we took a look at A here. Let's visually look. Is there any way that we could cut it and we fold it and it would be exactly the same? As you're peeking here, you will probably notice that no, because this right side here has kind of an angle to it, there's no way we could cut it right down the middle and fold it to make it equal. So no line of symmetry on A. Let's look at B. We have our arrow here. If I were to draw a line straight up and down, we can notice here that the left could go with the right. So it has one line of symmetry on B. And go ahead and draw your line then. The only place that we could fold this arrow in half and look identical is right down the middle. So our left and our right would be the same. So one line of symmetry there for B. All right, here's two new pictures. C. If we look at C, okay, it looks like we could probably cut it maybe left and right and fold it up and down. So it has one line of symmetry, and our line of symmetry there goes left and right to cut it in half. And look at D. Look at this crazy arrow here. Let's see, where could I cut it? Now when we cut it, we can only draw one line. We can't go kind of down halfway and then take a left, right? So we have to make sure that one line of symmetry cuts it in half. And in this case, there is no line of symmetry. All right, next then, find the lines of symmetry. It says find all the lines of symmetry in the figure. So letter A here, we have our diamond shape, and we are going to draw in everywhere we could cut it in half, basically, right? And there's actually two lines of symmetry in this figure. We can draw one right down the middle, so vertically, so our left and right would be able to match up, and we can also do a horizontal line, so we could fold it up and down for it to match. Let's look at B here. If you take a look at B, there is nowhere I can cut this banner that it would be equal. It kind of looks like if I cut it right down the middle, that should be in half, right? But however, on the left side, it curves down. On the right side, it curves up. So if we did fold those together, it would not match up. All right, letter C here. Take a look. Is there anywhere I could cut this? And I cannot, right? With this top side being at the angle it is, I would not be able to fold it in half and make it symmetrical. Letter D, our heart here. There is one line of symmetry and right down the middle, right? You can fold that down, fold it in half, and we would have then our line of symmetry.
Hello there, class. Mr. Hughes is back. We're going to talk about rotational symmetry. Rotational symmetry is a figure has rotational symmetry if, when it is rotated less than 360 degrees around a central point, it coincides with itself. So make sure we get that vocabulary word definition written down. Again, if we rotate it less than 360 degrees around a central point, it coincides with itself. The second vocab word that we have is center of rotation. Basically, this is the central point of rotation. If we were to rotate this object, what is that? What are we rotating it on? Well, typically we rotate it on the center of that object right there is the center of rotation. So as you look, we have a little flower shape here that we're going to look for how many times each figure will show rotational symmetry within one full rotation. Well, what we're going to do is this. We're going to take the center, our center of rotation, and we're going to draw lines from the center out through identical places in the figure. So we're going to go from here, we're going to draw it out, we're going to draw it out, we're going to draw it out, and we're going to draw it out. And those would be all symmetrical there. And when we do that, we're going to count up the number of lines that we drew. That happened to be 4. So the figure will show rotational symmetry 4 times within a 360-degree rotation. Our next example shows a circle we cut into 3 sections. And again, we're going to find the center of rotation, which happens to be right in the center of this circle. And again, just like we did in the previous example, we're going to draw lines out from the center. So we go out to the edge, out through the dot, and out through this dot to the edge. We know that we do count the number of lines. We did 3 lines. So therefore, it shows rotational symmetry 3 times within a 360-degree rotation. Here's a little star-shaped. Again, we want to find the center. And when we do that, we can draw lines out from the center. Okay, and as you can see, we went from this center piece right here is our center of rotation. 1, 2, 3, 4. So therefore, we have drawn rotational symmetry 4 times to get back to 360 degrees. And we're left with a very similar shape here in a square. Again, the center of the square is going to be our center of rotation. And we're going to go out to the edges, cut this thing in half. We drew it 4 times. Okay, so we count up the lines drawn. So we show rotational symmetry 4 times within that 360-degree rotation. That's basically counting up the lines of symmetry, or how many rotational symmetry in one full rotation. Your assignment's going to be 17.7 worksheet. Be sure that when you do divide the figures into symmetry, you do all of that and you show your lines of symmetry. You show that on both the rotational symmetry and identifying line symmetry. Have a great day.